this assessment asks whether we can make the ketone shown and redrawn here in good yield using alkyne hydration. Now, this is going to be an issue that we see when we're doing alkyne hydration, depending on whether we're using a terminal alkyne, an internal symmetrical alkyne, or an internal non-symmetrical alkyne. And so really what this question is asking is, will the alkyne we use to make this be terminal? Well, the carbonyl is forming in the center of the chain, so no. But will it be symmetrical? So let's imagine two possible alkynes. And we can do this by marking up our structure to say that the alkyne could be here or it could be here. Let's draw both of those possible alkynes and examine them a little more. So we could have the triple bond be here. We're going to want to make sure we have the number of carbons right. So 1, 2, 3, 4, 5, 6, and then the phenyl. 1, 2, 3, 4, 5, 6. And then the phenyl. So that would be one of the alkynes, not symmetrical. If we look at the other one, we'll start drawing it from the left or from the right. So we'll go up, then down. Here's our alkyne. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then the methyl. Again, you see the importance of counting the carbons to make sure we have that right. We notice that this alkyne is also not symmetrical. What does that mean? That means that at some point, if you recall in the mechanism of this reaction, and we won't go into it in too much detail, but in terms of the mechanism of this reaction, we're going to at some point have made a mercurinium ion. And how do we dictate where water is going to attack? Usually, it would attack at what would be the site of the more stable carbocation. Well, if both of these carbons are secondary, we're not going to get selectivity. And so we would end up with a 50-50 mixture where the oxygen adds here or where water adds here versus with water adding here. And so based on the fact that neither of these are symmetrical, we would expect to get that 50-50 mixture of regioisomers. This reaction will not proceed efficiently to give a single compound.